Question number 10. Now in this question, we need to find time complexity for this method over here. So basically with these methods, we are printing out the powers of 2. So for example, if I run this method with a parameter of 4, it will print 1, 2, and 4. So in this question, we need to find the time complexity for this method. Now if you look at carefully this method, in the first part of method, we have if condition. So this part will take O1 time complexity because in this case, we are not doing any time consuming operation over here. We are just checking if n is less than 1. So we are returning 0. If n is equal to 1, we are printing out 1 and returning 1. So this part of code will take O1 time complexity. If we continue down, you see that in the else condition, we are calling our method recursively. So we need to calculate the time complexity for this method over here. Now the rest part is, this part over here is just assignment statement and printing statement. So this part of code also will take O1 time complexity. So we need to find the time complexity for this part. So to find it, let's run our method for the parameter of 50. So if we run it, for example, in the first stage, our function will be run for the parameter of 50. Then in the second recursive call, the parameter will become 25 because here we are dividing n by 2. Then if we run it one more time, it's going to divide it by 2. Then we are taking the floor of this, so it means that we are going to run it for 12. Now if we run it for 12, it's going to run for 6 because we are dividing it by 2. Then 3, then it's going to reach to 1. Now when it reaches to 1, we see that when it is 1, it's going to print out 1 and return 1. Now in this case, after returning 1, we will multiply this one with 2 and return for the previous value. So previous parameter was 3. Then it continues like this. And each time we are multiplying the previous value for calculating the current value. If you go like this, so the last return will be 32. And in each step, we are going to print out these values over here. So the powers of that are less than 50 are these ones. So after 32, it becomes 64, so which is greater than 50. That's now it's going to print out over here. As you see in this algorithm, each time we divide our iteration into 2. So we have learned in the different types of run complexities that the number of times we can halve n until we get 1 is O log n times. So this means that the time complexity for this method will take log n time complexity. Because here in each step we are dividing our parameter by 2. So this means that recursive calls divided by 2. So that's why the time complexity will take O log n time complexity. So with this question, we have come to the end of this section. So in this section, I have explained the interview questions related to big O. So I have explained you how can we find time complexity for different methods. So hopefully you have understood everything. So see you in the next section.